Hello students, how are you all? I know nowadays temperature is rising and rising. Then also I am here again to take you on a cool topics. So take out your books, pencil, pens on the next episode of electricity. In episode 1, we have ended the episode with two words, that is ammeter, and next one was voltmeter. Ammeter, you know already that it is used to measure the electric current, and voltmeter is used to measure the potential difference. So ammeter are connected in series and voltmeter are connected in parallel. If we see the symbols of each one, that will be, for ammeter the symbol will be this one, and for voltmeter the symbol will be this. So if we see clearly here, left side it has given the diagram of an ammeter. Ammeters are generally like this, and then after in the right side, if you see, the ammeter is connected with the conductor in a series, one after the another. The next one, that is the voltmeter. If you see in the diagram here in the left side, voltmeter is there. If you go in the physics lab, you will be able to see that. And in the right part, we have seen that voltmeter is connected in parallel with the conductor. So this is all about ammeter and voltmeter. So the next one, we will be going over the topic symbols used in circuit diagrams. So there are various symbols present in it. So first one is the cell. So it has been symbolized as this one, bigger and small stick. It should not be the same stick, it will be wrong. Next one, if we combine all the different cells together, it will form a battery. So its shape will be, its symbol will be like this, positive and negative. The third one we will see, it is also given in the book. You can see nicely over there, the switch. So this type of switch symbol will be of opening of the switch, and this one will be the closing of the switch. Next, the symbol of wire. So generally wire is shown in a straight line. So this symbol shows that it is joined with the another wire, and this symbol is used to show the wire is crossing the another wire. So next we will see the symbol of bulb. Bulb is this one, and then after resistance. So resistance is has a symbol this one, and then after voltmeter and ammeter we have seen already its symbols. So this is all about the symbols used in circuit diagram. Okay, now we will see some of the things about the potential difference and the current. So potential difference symbolized as V, and then after current, that symbol is I. So if potential difference is high, then current will also be high, and if potential difference is low, then current will also be low. So that means we can say potential difference is directly proportional to the current, or if I take V by I, then it will give a constant rate, potential difference upon the current. So this is the resistance. This gives us the formula for the resistance. So resistance is V upon I, potential difference over current. So it is resistance and used as a symbol R. So this relationship between current and potential difference is called as Ohm's law. So if we look over the statement of Ohm's law, so it states that potential difference across the 2 points of a metallic conductor is directly proportional to the current passing through the circuit, provided that temperature remains the constant. So let's see the graph of Ohm's law. So we can see here potential difference is directly proportional to the current. The high is the current will be, potential difference will be also high, and low of the potential difference, then the current will also be low. So that constant is our resistance. So resistance, it is symbolized as R. Its SI unit is ohm. and is denoted by the symbol omega. Okay, so if you see the definition of resistance, it is the property of a conductor to resist the flow of charges through it. So we have already got the relationship between potential difference, current and resistance. And this relationship will be helpful for solving various numerical problems of this chapter. And it also called as the Ohm's law. So suppose a wire is there, AB, 1 volt potential difference and flowing 1 ampere of current. So our resistance will be 1 ohm. So 1 volt upon 1 ampere gives us the 1 ohm of resistance. So if we see the definition of 1 ohm, it states that when potential difference is 1 volt and current through the circuit is 1 ampere, then resistance is 1 ohm. Suppose it is a circuit where some amount of current is flowing through it with some voltage. So in order to change the current from the circuit, we need to change the resistance of the circuit. So this change in current will be done by the or controlled by a instrument called as the rheostat. And what its definition is, so rheostat is a variable resistance, is a component used to regulate current without changing the source of voltage. Okay. Now we will see some of the things that you know already you have got in lower classes, that is conductors and insulators. So what is conductor? A good conductor allows the electricity to flow through it easily. So electricity passes easily. So that means these conductors have low resistance. These conductors has low resistance. That's why electricity passes easily. And when we talk about insulators, they do not passes the electricity easily. Okay, so this means that the resistance is high over it. The resistance is high. That's why there is a problem in passing of the electricity. So if we come in between of these two things, we have the another thing, that is poor conductor. Poor conductor are those which limits the passing of the electricity, or we can say limited amount of electricity passes. So these poor conductors are used as resistors. Okay. Now we will solve some of the numericals. So here two diagrams are given here, and we need to find out the I, that is the current. Okay. So here 15 ampere is given in the first diagram if you see, and potential difference has been given 10 volt. So here what are the given parts from the first diagram? I am writing here. I1 is equal to 15A, V2 is equal to 10V, and from the next diagram we are getting I2 is equal to, I2 we need to find out, V2 is equal to 30V. Okay, so according to the Ohm's law, what we have got, that potential difference is directly proportional to the current. So we can write V by I is equal to constant. So from both this figure, we can be able to write V1 by I1, V1 by I1 is equal to V2 by I2. So both are constant, that's why we have written in equal portion. So putting the values here, we can be able to write, or we can be able to find out the answer. So I am writing here. So what we can find out from here, I2 is equal to 30 into 15 divided by 10. So I2 will be equal to, after cancelling 0 and 0, we are getting 45 ampere. So this is the solution of this numerical. So we got to know that V is directly proportional to the I, and V by I is always constant. So comparing the two diagram, we have found out the result. Okay, next question we can do. We have got 45 ampere, the result of earlier question. Now we need to find out the resistance. So again, using the Ohm's law, what we can write? What was the relationship between potential difference, current and resistance? So using this, we will find out the solution or the answer for the numerical problem. So I'm using the first diagram. So 10 by 15 is equal to R. So R will be equal to 2 by 3. After cancelling the things, we will able to get the result. So 2 by 3 ohm. So here also, if you see, same result will be coming over for this second diagram also. The resistance will be 2 by 3 ohm. Okay. I hope you have understand it nicely. So this much for today, students. So we are at the end of episode 2. We will again meet in the next episode. Till then, thank you and take care.